since we're in the REPL. Ha! On the REPL has from the beginning is the history of is pre-populated. So we have some examples. Here, for example, you can fetch code from the net via the URL. You can load that code. Does the stairs, and it automatically now fetches it from the web and says, I have a new module. Yeah, we can browse the module, browse stairs. Okay, here we do have a number of things in here. For example, this is an interesting type signature. There's something called fast and something called slow, which is IO unit. Means we can just call it fast. Oof. It's painting this doodle, right? How is it doing it? Yeah, it can ask slow.
Very slow.
This is to be called extremely very slow. But you can see it that if you would take it like so, you make these crosses, you peek over the edge and have a bearing and just extend this line just a little every time you go around. Then it goes like so. And the interesting point here is that that's painting on a JavaFX canvas, a little bit like turtle graphics or so. But turtle graphics are all changing state, mutating stuff, changing the world with every single stroke. And this piece of code is 100% functional, side effect free. Only when we later evaluate it will the IO actions be executed. That's pretty cool. How's that going? For example, you can say what slow is doing is we can take the doodle. Doodle is the actual algorithm that paints it. All the various actions that actually do one cross after the other, and we can play that with in the graphics context, and it goes like so, 300 stars. So, but what is the type of take 300 doodle? We have actually seen what the type of doodle is. Actually, take 300 is the same type, right? It takes a graphics context. It returns a list of IO unit actions. Ah, that is interesting. That means if I go back, take 300, I could do something like I first drop 200 actions, and then I do only 3 of them. Okay, that was this line, this line, this line. If I take another line, it will make the line from here to here, but just extend it slightly, 10% more. You know? Ah, okay. So that is take 4. Aha, so just so you see how that painting goes on, right? And since this is just a list, I mean, it is a list. What can I do with a list? I can put new stuff in the list. For that reason, I first need the help of import data list, unused import, thank you. And now from this take 300, I'm not dropping, but I'd like to make every second action wait just a little. I have all my actions that do this crisscrossing, and now I'd like to intersperse between every 2 actions a slight wait. Makes sense? So how do I do it? Intersperse. You have to know that one. And then a logic on how I intersperse, or some value actually. And that value is thread.sleep 10. A little bit bigger. That's how it goes, right? And now comes the trick, you know. Since that is a list, I reverse the list. Huh? Reserve. Thanks. Reverse the list. Now I could drop every second one, whatever, right?
So So thread.sleep has IO unit as the
Yes.
return value now?
Thread sleep is IO unit.
Okay.
Otherwise, it wouldn't compile. You
Yeah.
know? It's nice.
So that is
And I know you would like to know, see that code, right? Is that correct? What else there's doing? I would like would be in the. It's not in the REPL as such, so to see that code. This is the new one. Here it is. That's all the code. It's actually, yeah, it's a little bit more than one page. So module stairs. It uses the sketchbook. So the FX REPL comes with a sketchbook that allows you painting on a canvas. And from this, we only need one function, paint. And we need everything from JavaFX because we just take everything. Oh, sorry. We could take everything, but we only use graphics context from the 855 types in there. And from JavaFX utils, we have a function called withUI because the actions that we execute UI-wise should run inside the UI thread. And this function does it for us, making it, otherwise it wouldn't paint correctly. And we use data list. So here's a point, exactly like your complex one, yeah, with a double. And for making these, with these three, when we need to peek over the last but fourth element, we need to have the last four elements that we can, from this one, peek over the ones that was 4 steps before. We have to kind of, the last 4 elements, we have to keep track of those. We have a trail of points that follows us, right? And that is this trail, which happens just to be a quadruple. And then there's a start figure, 10, 10, 10, 10, almost 10, 10, 10, 10. The last one needs to be slightly tucked in, otherwise it would skew out of that thing. And here we have a function bearing, which takes a point and another point and returns a point. Okay, this is the one you have to figure out what's the direction for the next stroke, right? Oh, okay, that's my bearing, and then I go 10% further. It's a plain thing, or 5% further. And then I have a step where I have one trail and I produce the next trail. So I'm finding this, yeah? And that means a trail is just, you know, deconstructing on the constructor. First, second, third, and the last one. And the new one is the bearing from the first over the last. You know? Makes sense? And then the other ones are just trailing behind. What has been the first before now becomes the second one, second position. And all trails, it's just a list of trails. But it's an infinite one. We use iterate, which takes a start value and an incremental value. So how do I make the next increment? And we produce an infinite amount of these things that we later just take so many of. It's kind of rather interesting. This is and you know, you see, do we have IO action somewhere? No. It is all purely functional. It's a purely functional thing. It's not like turtle graphics, pen down, go forward. No. But at some point, we need to have to connect the dots, connect the points, right? For this, we need the graphics context. And connect gets the graphics context. And once it has it, it only needs from the trail the first and the second element because it can just connect them. And we do this within the UI. We provide a function that on the context does a stroke line. This is, you will actually find it already. That directly comes from JavaFX. And the XY of the half position and the XY of the next position, that just makes the line. This is IO unit. But at this point, it's not yet executed. It's not a side effect. It's only an action that will later be effected. We store that action. It's still purely functional. And the doodle does nothing else than taking the trails and mapping the connection of dots over it. You know? I like that so much. You can see me excited. And then we use the paint, which comes from sketchbook, which knows the canvas, where you need to know the canvas, and canvas has the graphics context and so on. It passes us the graphics context. So at this point, the sequencing function does the actual side effect. Right? Sequencing means that I take a list of actions and I execute the actions. This is the only when we do this, we will see the actual effects. Right? This is the only one that's no longer purely functional. The one line, which is no longer purely functional. And then the other ones are just sample usages that you can use directly in the console. And what I also like, I use this kind of notation for documentation, such that in the REPL you can ask help for what is that, for example, doodle, and it will give you, it's not only in the source code, it is in the bytecode. The documentation is in the bytecode, just like in Python. Right? Therefore, even if you only have the jar, but you still have the documentation with you. I like that. Currently it makes sense to have the right documentation. And then you can just jump into whatever this is, IO, whatever, from here.
I'm just thinking about it, but if